So that brings us to Wednesday, 7 in the evening. Try and get some of this done, if not all of it. And it's Harrier CB, as you can see, in its box. And my customer has bought this on eBay, and the eBay vendor has sent it straight to me. Then I'll send it to the customer. So I get to open it first. And isn't it nice to see one in a box? Wouldn't it be even nicer if it came with an instruction book that I can scan? Oh look, it comes with an instruction book I can scan. That's fun. What's this say? Installing a CB radio. Oh good. Factory mic. Power lead. Mind you, I think he paid about 54 quid for it, so it didn't come free. And even we have a little fee as well. It's come with the bracket and the side screws. Wow. So these were $69.99 when new in 1981. Cybernet 134. Oh my goodness, it's still got the seals. Ah. No, it is broken. I think it's broken anyway. Well, it's going to be broken in a minute. Beautiful. I'll get that screw out. I bet this still smells of new CB when I open it up. That has a unique sound, unique smell. They could do a car air freshener, couldn't they, called new CB smell. As you know, I'm a church organ builder for huge pipe organs in churches, and pipe organs have a unique smell, and even when they're 150 years old, they still smell of church organ. You know what? That seal is intact. No, you can't cheat it. Well, I never thought I would see a sealed set from 38 years back. Right, we'll connect it to the test equipment. We'll do some checks. Tell you what I'm going to do, I'll just pop this on the photocopier, and I'll write on the reverse side the before and after. Oh, don't tell me that's not right. We're not putting that on the photocopier. So pinch a piece of paper out of the copier. It wants me to do some cleaning routine, and it won't let me do anything until I have, so I don't think so. So it's probably doing about 3 watts, probably doing about 1.4 deviation but the receiver will be pretty well spot on. That's been my experience, the way they're set up in the past. So we'll select picture in picture, press transmit, go on the 3 watt scale, so full scale deflection is 3 watts. Helps if we switch the CB on, it actually helps if we plug the power lead in. I'm a stage ahead of myself there. I think Mr. Chippy's chewing at the bit to do a on the air test, so it'd be nice if we got this done. And then we can test it and it can go straight back to the customer. It's only been here a week. We have to join the queue, you see. And we can't do CBs always every day. So, switch on, take it to channel 20, press transmit. And just plug the lead in. It's beyond 3 watts, doing 3.1. Transmit frequency. Should be 27,79125. It's slightly low, of course. They drop with age. So we'll just pull that up with the crystal trimmer next to the crystal. It's still well within spec, there's no problems at all. There we go, 27,79125. That's one job done. I'm going to check the VFO for the VCO for the sake of it, but with it being a new set, as in sealed and not messed about with, this shouldn't be an issue at all. So we're looking at 4 volts on channel 40. So between ground, which I'll use the power supply negative lead because it's a floating chassis on these, and resistor 4, I think it is. I'll put the other glasses and I might be able to see. Yeah, resistor 4. Actually, it needs to just pop down a fraction. And on transmit should also be around 4, so that could do with popping up a fraction. These are neither here nor there where they are on this radio. There's no reason for it to be dropping channels off how it was, but just for the video we've got it at 4 on transmit and 3.99 on receive. We'll pop to channel 1. It should be around about 2.25 and not be exceeding 2.5. That's your transmit one, so that's spot on. Quickly put it back to channel 20, or I'll forget and tune the radio up on a different channel, and that would be silly. So we've done that. We'll just seal that back up. Transmit. Oh, we need to go into that camera for you. So transmit, it's now 3 watts. That's peak, peak, peak. Now we move on to those PA ones. I expect I'll have to look at the service manual because I always do. Maximum, you know what, that's the old one which is worn. Always pick up the worn one. There we go, that's the not so warm one. So that's now 4.4 watts. So we tune it to maximum. So that is absolutely maximum. And then the idea is what they tell you to do. I've done this before if you've been watching what I do on this channel. Where on earth is the service manual? Was on the wrong pile, wasn't it? So L4, which is that one, we need to rotate clockwise to obtain 4.4 watts. So if it was more than 4.4 watts, we turn it clockwise so it just starts to detune. And then L9 we turn anti-clockwise. Now the manual says for 3.8 watts. But of course the manual is assuming you've got to send container loads of this to a foreign country, and that customers are going to check them at the other end, and if they found one that was 4.01 watt, the whole batch would be rejected. This is why they always set things on the rather careful side, shall we say, and they still do. So the trouble is with a lot of sets is they don't come up to what we would like them to come up to. So there we are, your full 4 watts. Now what we check is that it's somewhere close to that. On channel 40 it's 4.05, and on channel 1 it's 4 watts dead. So it's pretty well balanced, and that's what we want. Now we shouldn't need to use that service manual again, so I'll put it back on the wrong shelf. One thing that plays up on these, and I don't expect this is any different even if it's newish, but we'll see what the low power is doing. Now the low power switch at the back is supposed to make the radio go to 0.4 of a watt. It's actually not working at all, and that's not unusual. Now I was nicked off with my service sol switch cleaner. Just pop some of that on there. Put that back where it should be. We'll just waggle that around because I think it needs a bit of waggling around. And there we are, we're working now. So there we are, 0.4 of a watt. Switch back to the 30 watt scale, switch to full power, 4 watts. So it's 4.05, it's gone up a bit as the set's cooled down. So that's the transmit done. We want to make sure the meter on the front says something like 4 watts. It says just over. So we'll adjust the preset there. See how many sets have got a power meter on them these days? They just have a pretend one. And I've taken out PA transistors and the sets no longer transmit, but the meter says it does. It's all smoke and mirrors these days. Show you what they want to show you. So that's that. We'll just check deviation. We never put that on our little list. Wallow. Looks like I've got to retune my thingy. Wallow. 1, 2. Wallow. Wallow. I can get 1.4. Just what I thought. TX deviation. 1.4 kilohertz. So we need to pop that up to 2.2 with an absolute maximum peak of 2.5. So that we want that control. The one on its side to its center position. And then we want this one probably to about 2. Let's give it a go from there. Wallow. It still wants a little bit more. Wallow. 1, 2. What it could do with a fraction more. 1, 2, 1, 2. Wallow. I can just about get 2.5 out of that with an absolute wah of a wallow. So that's done. So that's transmit done. So we'll go over to receive. I'll plug in our test instrument speaker thingy. And we've put 2779125 on the signal generator. Just like that. And let's have a look at where we are with the receive as it comes. RX is, we'll go over to the synod meter so you can see that. That's 12, 0.4. We could say 0.398, but we'll say 0.4 microvolts for 12 dB synod. Now, it's supposed to do better than 0.5, so it's already doing better than 0.5, but we'll still tune it, see if we can get something more out of it on receive. You never know, the customer might end up with another 10 feet range. So I'll take the bench light off. We're now going to do the detector, or the discriminator. So our FM decoder demodulator chip is there, and the adjustment for it is there. The oscilloscope is simply connected across the speaker. All we're looking at is audio, and look at that, we have an improvement. We've now maximised that, so that's another thing done. Here we go with the front end. So we'll set that so we've got about 4 or 5 dB. We'll go through the front end. Remember, I've got more time to do these than they do at the factory. Let's just put that up a bigger signal. So that's it. You haven't got as many receive stages as you have on some of the bigger models like the Rotel 230, Harvard 420M, and things like the Midland 76900 base station, the Harrier base station have got an extra coil there as well. So now we've done that, let's see what we're now getting. Right, we're borderline. So as ever, I'm between ranges. So on my 0.3 range, it's showing 0.32. And on my 1 range, it's showing 0.315. So we've got a bit more out of the receive, which is great news. So we'll put the signal generator now to 100 microvolts. I'll show the attenuator controls. Big one's on 100, that's on 10. And what we're going to do is check the squelch out. Oh no, we're not. We're going to do the signal meter. So it should read exactly S9, and it reads 8. So with the signal meter preset, we can adjust that. So 100 microvolts is S9 on a CB in the UK. So that does bring us to the squelch. So we'll turn down the signal generator to 0.3 microvolt, turn the squelch to full on the radio, and we'll turn up the signal generator. I want it to come in. It's muted at the moment because I've got the squelch on full. I want the squelch to open up when I put a 100 microvolt or S9 equivalent signal onto the radio. So that's 1, 3, 10, 30 microvolts. The next step is 100. It comes in. It's exactly where I want it to be. So the factory setting's absolutely right. But if it wasn't, it's the preset just there. So what we'll now do is take the squelch to the other end, switch the signal generator to standby, and I've parked the signal generator at 0.3 of a microvolts. When I switch it back on, that's where it will be. So turn the squelch down. That's threshold. They're not the best squelch in the world on the Cybernets, but they're competent. Switch the radio with the signal generator on. So let's see where it's coming in and out. In fact, let's just start again with that test. It's coming in at 0.75 of a microvolt and leaving about 0.69 of a microvolt. So that's fine. We're done. Nothing more to it. So the radio is in perfect working order. We've brought the power up from 3.1 watts to 4 watts. Brought it up on frequency. That was neither here nor there. What was important, we brought the transmit deviation up from 1.4 to 2.2. Otherwise people have said you were quiet. And we've improved the sensitivity on receive from 0.4 of a microvolt to 0.32 of a microvolt. And you can't really ask for more than that. So it's a lovely radio in lovely condition, and it works very well. Someone's had it for 38 years not working to its peak. They probably never used it, probably bought it for that rainy day that never happened, saw it in the sale, thought, oh, I might get into CB one day. It didn't. These people then pass away, and the stuff either ends up in skips, or it ends up sold on eBay, or it ends up in a skip and finds its way to eBay, even better. I love having a skip in a town. I mean, here it doesn't, what I'm going to say isn't valid, but in a town, if you have a skip delivered, then you fill it with all your stuff, and the next day the skip's still full, but it's totally different contents. The stuff you put in isn't there, and the stuff you didn't put in is. It's fantastic. I'll just tell you my power supply is at 13.8 volts. We'll now disconnect the radio from the test instruments. In fact, I may as well switch the test instruments off because we won't be doing any more today. And we'll plug the aerial in. We'll have a quick whip round on the channels, which we won't find anybody because we never do. Then we'll do a scratchy corner test with Mr. Chippy. Well, Nana Roger. Bit of something there. Right, I'll park it there ready for Mr. Chippy to do a test. So that's a nice radio, it's worked out well. Thank you for watching the Harrier CB from 1981.